To solve logs by approximating, what we need to do is get our bases of the same, which they are, they're both 4, but then we also need to get our logs. So there's 3 and 192. So we need to get 192 to a 3. So to do that, I'm going to take 192 and divide it by 3, and I get 64 when I divide it by 3. So I just wrote 192 as 64 times 3. Now what we want to do is take the 64 and write it in an exponent. So in that case, 64 is 4 to the 3rd power times 3. So I just rewrote 192 as 64 times 3, and then 64 I wrote with the power of 4 to the 3rd power. Now by doing that, I can now replace these two, because the property that we're going to use is multiplication property, which simply means you can separate with the same base each of the logs into addition when they're multiplied. So what I have is this. Now, another property is that when we have an exponent, we have to write that in front of a log. So it's 3 times log base 4 of 4 plus, and we know what the log of 3 base 4 is. It's actually 0.7925. So now we need to figure out what log base 4 is. Now if we go back to what logs mean, it's what exponent gives us 4. So really this, when it's the same base and the same log, is really 1. So what we have is 3 times 1 plus 0.7925. And when I add those up, I get 3.7925. And so that is the approximate value of log 192, right up here. Once again, we are given this information and we want to evaluate or approximate this. So we're going to change our log base 2 of 25, and I'm going to change it to 5, divided by 5. So basically log base 2 is going to be 5 times 5. Well, 5 times 5 is really 5 squared. And then the property we're going to use is, like I said in the last slide, is this exponent is going to get moved to in front of the log. So it's going to become 2 log base 2 of 5. And now we have this approximation, which is given right up here. So I'm going to replace that. So it's going to be 2 times 2.3219. And when we do that math, we get, so finishing this problem, when you multiply, we approximately, not equals, because all the logs are approximation unless they are the same base. So we get our answer 4.6438. So the approximation of this log is 4.6438. The key to these problems is writing the log in with the same that's given. So that's why I changed it from 25 to 5 times 5. And when you have an exponent, the exponent gets moved in front of the log as a multiplication. To solve these two type of equations, when the bases are the same, the property says if I take that same base, I can multiply the log. So x times x minus 9 equals 2. Now to solve logs, we have to change an equation. So we go back into converting logs into equations. So basically we have our base of 6 to the 2nd power equals x times x minus 9. All I've done is take the log and the base and the exponent. Now this is 36 equals x squared minus 9x. To solve any kind of quadratic, we have to get it equal to 0. So I'm going to subtract 36 from both sides. So it equals 0. And once I have it like this, I can factor. So we can factor this equation by what two numbers give us a negative 36 and add up to a negative 9. And those two numbers are negative 12 and a positive 3. So now this doesn't mean it's solved. I've just factored it. To solve it, I have to set each factor equal to 0 and solve, which is 12 one answer, and x plus 3 equals 0, and subtract 3, I get negative 3. And so my two answers are 12 and negative 3. And that's solving using the properties.